Old school versus modern industry process starts with breaking down scrap iron into smaller, manageable pieces. These fragments are then placed into a furnace, where temperatures can exceed 100 degrees Celsius to 192 degrees Fahrenheit. At this point, the solid metal transforms into liquid, crafting the clay mold. While the metal heats up, a skilled worker prepares a custom clay mold. This isn't ordinary clay, it's a carefully mixed material designed to withstand extreme heat without cracking. The mold determines the shape, size, and structure of the final gear. So yeah, no pressure. For precision in mold making, creating this mold is one of the most critical steps. Every curve, every edge must be accurate, because whatever is inside the mold becomes the final product. This process requires years of experience, steady hands, and a deep understanding. Gas escape system smart engineering. A circular plate is added, and small holes are carefully created in the mold. These aren't random, they act as vent channels. In places like the United States, large-scale factories rely on CNC machines and automated systems to mass-produce gears with extreme precision. But here in Pakistan, something completely different is happening. When molten metal is poured, gases and air need a way to escape. Without these vents, pressure can build up and create defects like bubbles or cracks inside the gear. Simple technique, but seriously smart engineering. Now comes the most intense moment. The molten metal is carefully poured into the mold. The mold is then sealed tightly to ensure proper shaping and solidification. At this stage, the metal begins cooling and transitioning from liquid back to solid, a process called solidification. This is where the gear truly takes form. 7. Breaking the mold. Once the metal has cooled and hardened, the outer mold is carefully broken away. This reveals the rough gear casting, still covered in residue, still imperfect, but structurally complete. Think of it like opening a package. Except it weighs a few hundred kilos. 8. Shaping the gear teeth. Next comes refining the gear teeth, one of the most important parts of the process. The teeth are shaped and adjusted to ensure proper meshing, which allows gears to transfer motion smoothly between components. Then the gear is mounted on a lathe machine, where it's polished and balanced. This reduces friction and improves efficiency, because smoother gears last longer and perform better. 9. Final result. Strength and function. Despite using simple tools and traditional methods, the final product is surprisingly strong and reliable.